When 20 pounds of pepperoni pizza hits a steel prep table, thick steam billows from the edges of a golden artisanal crust. Maintaining this quality at a 28-inch diameter is a serious test of structural scaling. The build must navigate extreme geometry and volatile temperatures to prevent a total collapse. Managing those forces requires three specific components: high-gluten flour for tension, a 550-degree oven for rapid rigidity, and nearly 20 hours of total preparation time. While a standard 12-inch pizza covers about 113 square inches, expanding the diameter to 28 inches increases the total surface area to over 615 square inches, multiplying the load-bearing requirements. At this scale, a standard recipe fails. Success requires the same precise calculations you would use for a structural engineering project. The foundation is the core physical challenge. The base must be strong enough to support massive moisture and weight without turning into a soggy mess. Using high-gluten flour provides the mandatory protein network needed for this level of extreme structural integrity. For an 8-pound dough batch, add the water, flour, salt, and yeast to the bowl first. Mix on low for 1 to 2 minutes until a shaggy mass forms, then slowly drizzle in the oil. These massive dough batches trap and generate significant internal heat. Attempting a traditional room temperature proof makes the rise highly volatile and difficult to control. You must use a cold environment for a strictly monitored 16 to 18-hour bulk fermentation to manage the internal temperature. When you pull the cold dough the next day, you will see a complex, tightly knit, web-like gluten structure, the primary indicator of a successful ferment. This slow-fermented, high-gluten foundation is the single factor that prevents a catastrophic structural failure during the bake. The stretching phase is the highest risk point of the operation. Cold dough contains high tension, and we tear immediately if you force it. A 2-hour rest at room temperature is required to chemically relax the gluten network, allowing the dough to expand without snapping. Avoid spinning the dough. Instead, gently press and stretch it evenly across a specialized 28-inch pizza screen. If the dough shows extreme resistance or snaps back, stop immediately. Let it rest for 15 minutes before attempting to stretch it further. This deliberate, patient stretching is the only way to safeguard against a fatal mid-bake breach in the crust. The assembly phase introduces a new threat: the moisture load from nearly 10 pounds of wet ingredients. Standard watery sauce will liquefy the dough center. You need 4 pounds of thick, highly reduced pizza sauce to protect the structural integrity of the base. Over that dense sauce layer, you must carefully apply a massive 5 pounds of freshly grated whole milk mozzarella cheese to cover the entire expanse. You must leave exactly 1.5 inches of bare dough around the entire border. This provides a vent for steam and allows the crust to rise. Finally, pave the entire surface edge to edge with 3 pounds of natural casing pepperoni. Managing the moisture density and weight distribution in this specific layout ensures the pizza bakes into a solid structure rather than boiling in its own juices. Launch the pizza into an oven preheated to a blistering 550 degrees Fahrenheit. Intense bottom heat must rapidly rigidify the crust to secure the base before the massive top load liquefies. Simultaneously, the ambient heat cooks the top layer, causing the pepperoni to cup upward and trap the pooling oils. This dual-action heat is the final crucible, transforming 20 pounds of raw ingredients into a single rigid structure. The finished pizza emerges from the oven with a rigid bottom and a deeply charred, bubbly crust. At this scale, you need an oversized, two-handed pizza cutter to roll straight through the density of the bake. Lifting a slice reveals the final proof of the build, an airy crumb structure that holds its own weight despite the heavy load. Applying these principles of physics turns 20 pounds of raw ingredients into a communal meal that standard cooking methods simply cannot produce.